Hello friends, welcome to another tutorial in basics of electromagnetics. In this tutorial we'll do a very basic thing, which is converting a rectangular coordinate system point or a vector into a cylindrical coordinate system point or a vector. Now please understand, this video is all about the conversion of one coordinate system into another, so I'll not go into the details of the coordinate system itself. However, I'll touch upon the basics, so let's get straight into it. When we talk about rectangular coordinate system, the point will have coordinates as x, y and z, and when we talk about cylindrical coordinate system, the points will have r, theta and z. And it is very important to know how these points look like in a three-dimensional space. So it's just a matter of perception, by the way. So I'm taking up this point, for example x, y, z, in a rectangular coordinate system, and x will tell me the amount by which this point is away from the origin in the x direction, and the distance in the y axis will be given by the y coordinate, and the height, so as to say, will be given by the z coordinate. So you can see that in this coordinate system, if I have to measure the distances x, y and z, I'll have to drop this point on the xy plane to get the x and y distances, and the height of this point from the xy plane will give me the z. That being said, you kind of get a picture of a cuboid or a cube. Now, while drawing a point in a rectangular coordinate system, you kind of picturize a cube or a cuboid in a quadrant, and there could be 8 different quadrants depending upon whether z is positive or negative. So that's how you get a picture of the rectangular coordinate system. However, if we go on to draw a point in a cylindrical coordinate system, please understand the point is still the same, but the depiction has changed. So let us say we have this point. Now this point is considered to be lying on the surface of a cylinder, and whose quarter part is just shown in this quadrant. The point is lying on the surface of the cylinder, which if you drop this point on the previously assumed xy plane and you measure the distance of that point from the origin, you'll get the radius or the r. And if you measure the angle of this point from the x axis, you'll get theta, which is the second coordinate, and of course third quadrant remains the same, which is z, which is the height from the surface. And it will not be appropriate to call it as the xy plane, because xy no longer are existent in this coordinate system. So what we are left with is the radius of that point and sort of angle theta, that, and the height, which is z. So there is one similarity between rectangular coordinate system and cylindrical coordinate system, which is the third coordinate, which is z. So z represents the height. Another important thing to understand is the ranges of the coordinates. So if we talk about the range of x, x could take a value anywhere between positive infinity to minus infinity. If you extend x in the other direction, you can take x to minus infinity, and similarly y will also get a value from minus infinity to infinity. All the points in rectangular coordinate system, they have ranges from minus infinity to infinity, whereas if we talk about cylindrical coordinate system, the range of r could be from 0 to infinity, because radius cannot be 0. If you form a cylinder, you'll surely get some radius, so it'll be 0 to infinity. Theta can take up the range from 0 to 360, because it can go full circle, so you can be in the first quadrant, in the second quadrant, in the third, and in the fourth quadrant. Now, depending upon the value of theta, your r will either lie in the first quadrant, or in the second quadrant, or in the third, or in the fourth quadrant, and you can guess that the value of z could lie from minus infinity to infinity. So that's one important thing that you can remember. Have a clear picture of cylindrical coordinate system in your mind. And next, we have a set of relations between rectangular coordinate system and cylindrical coordinate system that you can commit to your memory, that will help you solve the numericals. These relations are derived from geometry. For example, x is r cos theta, y is r sin theta, and z is z. So this is one thing that does not change, and theta is tan inverse of y upon x, and the radius is x square plus y square. Radius square is x square plus y square. So if you can dig deep into the derivation of these relations, because this is pure geometry, going from one coordinate system into another. We can talk about this in some other tutorial, but in this tutorial I am focusing only on converting a rectangular coordinate system into cylindrical coordinate system. For example, you have a numerical in hand where you wish to convert a point 4, 4 minus 7, which is of course in rectangular coordinate system, to cylindrical coordinate system. So your first step will be to identify x, y, and z, which is very easy. Your x is 4, y is 4, and z is minus 7, which is pretty easy to comprehend. And once we know this, we need to find r, theta, and z. That will give me my point in a cylindrical coordinate system. So that's what the first question is all about. Now you can clearly see that your z is minus 7, so it remains minus 7 as it is. So the first step will be to write the value of z or z as minus 7 as it is. And the second step is to find r. You can find r as x square plus y square under root from this relation, and you get 4 square plus 4 square under root, and you get the value of r to be 4 multiplied by root 2. So the second thing is done. So out of r, theta, and z, I found z, r. Now what is left is theta. You could use this relation. Theta is tan inverse of y by x, and tan inverse of 4 by 4 gives me tan inverse 1, and that gives me 45 degrees. That is how you can find the coordinates of this point in the cylindrical coordinate system. Now there is something that you need to take care of. If you've taken the value of r, you could get possibly two values here, plus minus root 32, and if you have taken the positive value, you must see that theta corresponding to that positive value is 45 degrees. So that you can take care of. And another question in this domain could be something of this sort. You want to convert x square plus y square minus 4x is equal to 0 into cylindrical coordinate system. So what you can do is, you know this relation x square plus y square is equal to r square. So instead of putting x is equal to r square cos square theta and y is equal to r square sin square theta, you can simply put this thing to be equivalent to r square in this equation. So this is my equation that I wish to convert to cylindrical coordinate system. So in this equation, these two terms can be directly put up as r square, and what I'm left with is minus 4x. So minus 4 into x is r cos theta, so I can write minus 4 r cos theta. So putting all this in equation A, I get r square minus 4 r cos theta is equal to 0, and then I can write r square is equal to 4 r cos theta, and I can write r is equal to 4 cos theta, and this equation is an equivalent equation of this equation in cylindrical form. So that's how you can convert a point or a vector in rectangular coordinate system into cylindrical coordinate system. And I hope this quick tutorial was of help. If you liked the video, give it a thumbs up. Consider subscribing to the channel as well, and share this video to your friends. I'll see you around in the next video. Take care. Bye bye.